In these two examples, we are going to look at some more ways to solve quadratic equations using the zero product property. Let's take a look at the equation on the left. The first thing we should notice is that this is not in standard form. And the reason I know it's not in standard form is because I do not have 0 on one side of the equal sign. So in order to put this equation into standard form, I'm going to add 2x to both sides, and I'm also going to subtract 9 from both sides. After I do that, I obtain 2x squared minus 3x minus 5 is equal to 0. Now I'm ready to factor my quadratic equation because I have the left side in standard form. So I notice there's no GCF and my a value is 2. This prompts me to use the AC method. So 2 times negative 5 is negative 10, and I want factors of negative 10 that will add up to negative 3 in the middle. So I want the 2 to be positive and the 5 to be negative. So I'm going to take my trinomial and turn it into a 4-term polynomial. So this becomes 2x squared plus 2x minus 5x minus 5 equals 0. And now that I have my 4 terms, I can split it down the middle and I can do factor by grouping. So on the left side, the GCF is 2x. So I have 2x times x plus 1. Now, on the right, when I say on the right, I mean after I split my 4-term polynomial into 2 groups of 2. My 2 terms on the right, I have negative 5x minus 5. The leading term, negative 5, is negative, so I want to use a GCF that's negative, and they also have 5 in common, so I want to use negative 5. And then after the sign change, that also leaves behind x plus 1. So I know that I'm on the right track because my binomials match. So the 2x minus 5 make up the first set of parentheses, and my x plus 1 makes up the second. So now I can create my two linear equations. So 2x minus 5 equals 0. So I would add 5 to both sides and then divide by 2. So my first solution is x equals 5 halves. Then I have x plus 1 equals 0. If I subtract 1 from both sides, I get x equals negative 1. So my two solutions are x equals 5 halves and x equals negative 1. Let's look at the second example. This one is not in standard form either. I'm going to have to subtract 30x from both sides in order to make my equation equal 0. So now you'll notice I'm not quite in standard form. I mean, I have everything on one side of the equal sign, but when I say I'm not quite in standard form, I have a cubed. So I want to factor this into two binomials, but I have my highest power is 3 on my x. If I look at all the terms, I hope you notice that there's a GCF, and the GCF is 2x. So once I take the 2x out, then it becomes something that's a little bit easier to factor. So now the trinomial that I want to focus on is x squared minus 2x minus 15. So don't forget about your GCF. Notice every time I write a new line to my problem, the GCF is going to be right there. So I have the 2x on the outside. Now I'm going to factor the trinomial x squared minus 2x minus 15 into two binomials. And the numbers are negative 5 and 3 because they multiply to negative 15 but add up to negative 2. Now, it's very important to recognize here how many solutions you're going to get. If you go back up to the original problem, you'll notice the highest exponent was 3. The highest exponent in your equation tells you how many solutions you're going to have. So since this was a cubed, it means I'm going to have 3 solutions. So by recognizing that, hopefully it makes you not forget that GCF of 2x helps you get one of your solutions. That's the thing. If we forget about that GCF, then we totally miss one of our solutions. So we're actually going to get 3 equations out of this. 2x equals 0, x minus 5 equals 0, and x plus 3 equals 0. Then when we solve these 3 equations, we get our 3 solutions. So x equals 0, or x equals 5, or x equals negative 3. Those are our 3 solutions to this problem.